Hello everybody. Welcome to the November 2020 version of the San Jose Astronomical Association Imaging Special Interest Group meeting. And tonight is posted as a general discussion, but we have some stuff that Glenn put together on spectroscopy and on more on equipment variations and anything that anybody wants to talk about. We're open to it. I think we'll have time. So um, why don't we get started? Glenn, you want to take it from the top?
Sure. Whoops, I think I went a little too quick there. I need to press one more button. Okay. All right, can you see the slide?
Yes.
Okay. So I put this together partly for you guys and partly for me just to document the different, I call them instrument packages that I'm using with my scopes because I don't want to forget, how many spacers it took to come to focus with one of these things and then have to spend time refiguring that out. So I thought I'd put it all down in PowerPoint, and that way it'll save me some time, and hopefully it'll be interesting for some of you as well. So the point is that the different types of astrophotography have different requirements, and so I'm talking about deep space, and you could divide that into kind of wider field and deeper targets, smaller FOVs. Then there's planetary, which there's some common requirements across the whole thing, but then you could divide it down into the planets themselves versus solar. And then another one that I've gotten motivated about again is the spectroscopy. So I don't know if you guys saw the last speaker after the board meeting was Tom Field, who writes the RSpec software that a lot of people use for spectroscopy. So there was a good talk on that, and that got me geared up to get back into that part of the hobby. And I had a piece of gear that we'll talk about here called a Grism that I had bought back in 2018 that I hadn't actually deployed or tried until now. So
Hey, Glenn,
yeah,
recorded? Was that recorded?
that particular, oh yes, yes, Tom's was recorded and it's on the SJAA YouTube site. I can send you a link later or something. But if you just go into YouTube and put in SJAA, you should find the channel. And yeah, back in 2018, I had given a talk at one of these SIG meetings, but it was before we were recording things. And at that time, I had just the star analyzer grading that we'll talk about that as well. So anyway, some stuff about spectroscopy, and I'll bring you up to speed on what I did in the last week on that as well. So diving into deep space. So this is my workhorse rig here. All of these, by the way, plug into Moonlight 2.5-inch focusers, either on my William Optics 80 millimeter triplet, Megres 2, whatever refractor, and also on my 12-inch truss RC. So I've kind of standardized on the focusers, and I have actually 3 of them now for some reason. so everything threads into one or the other of the focusers. So just in review, what you're usually trying to do for deep space is you want faster optics. You're trying to have a smaller focal ratio than maybe your native scope has, and that's to limit exposure time. It gives you a little wider field, and maybe you're trying to utilize as much of the flat image circle that your telescope can produce as possible in terms of getting all of that flat area on your camera sensor. So this particular rig here can go on either the 80 millimeter or the 12-inch RC, so without making any changes. So that's kind of handy. So if I want to do wider field, I can move it to the refractor, and if I want to go deep, I can put it on the RC. So this, let me put my mouse over here. This focal reducer goes down inside the focuser up to these threads here. And then we have the ONAG for guiding. So the infrared light goes straight through to the guide camera, and the visible light bounces off a cold mirror and goes through the filter wheel and to the ASI 1600. So that's my deep space rig. And this is what it looks like on the RC. I have since moved the electronics for the rotator off of this onto the RC OTA itself, because when I'm spinning things on and off of here, this keeps running into stuff. So that's one change that's been made since then. I think everything else is pretty current. Yeah, so again, oh, and also, I've talked before about my somewhat 3D printed rotator. The Moonlight focusers have the ability to add a rotator to them, and I, rather than buy the one that they make, I made my own using mostly designed from somebody on the net, and it's our Arduino and some 3D printed parts and stuff. So that's nice, and it's especially nice with the anytime you're doing off-axis or on-axis guiding versus a separate guide scope. Every time you rotate the camera, you'd have to recalibrate PHD2. But if you have a rotator with an ASCOM driver, then PHD2 can watch that and it can do the math, so you don't have to recalibrate. So that was one reason for me adding a rotator versus just doing the manual rotation with the manual rotator driver in SGP to prompt you, 3 more degrees, 3 more degrees or whatever. Okay, let's see. Yeah, so this gives me, on this rig anyway, it takes it down to f6.3. There's my FOV and arc minutes. And yes, it's still oversampled, but I can't have any more focal reduction because I'll run out of back focus. So unfortunately, that's one downside of the ONAG. And if you remember my talk on the ONAG, using it with the focal reducer is quite painful because this distance through the ONAG is so far that creates the amount of focal reduction. And as you increase that or have that big a distance, it eats back focus. Your OTA to sensor distance keeps shrinking, right? So that involved even with taking all the extension tubes off the scope that would go between the scope and the focuser. I still had to mechanically shave threads off the focal reducer to get the extra 10 millimeters I needed to come to focus. So that's why I'm still at 0.41 arc seconds per pixel.
Hey, Glenn, a quick question.
Yeah.
The bottom image on that last slide, you can see on the back of your camera around your fan, you have some things protruded there. I was wondering what those are.
What's the name of those silent fans, Bruce? The Nocturna?
Noctua.
No, okay, thank you. So yeah, my camera is outdoors, 24/7, 365. And I've also been lazy about leaving the power on, which I think sometimes it seems like the fan runs. Sometimes it does, and sometimes it doesn't. I'm not sure what that is. It's not cooling, but the fan still runs. But anyway, after however many years I've had this camera now, 3 years, the fan died. And I think Hi just went through that as well. So, looking to Cloudy Nights for help on that, since spare parts are not available for ZWO in any kind of convenient way. Uh, the thinking there was, rather than replace it with as close to the exact same fan as possible, that people were putting these other fans in there. And that had to do with people that were suffering from vibration problems more than anything else. But I just decided to go that route. And the way that particular fan mounts is, rather than having screws, and this helps with the vibration control, it has these silicone plugs that you pull through this. So you pull them through the fan, and then you pull the fan against the metal by pulling these four things through the screw holes. So that's what that is. And I could cut them down, but whatever. They're not hurting anything. They're soft.
Okay, thank
Okay.
you.
All right. So then here's what it looks like on the Megres 2 William Optics scope. So it's the same instrument package, and you get kind of another view of the rotator here. Here's the solenoid for it and the belt. I had, now that I'm in winter again, my friction fit gear for the belt is slipping a little bit, so I have to figure out how I'm going to keep that from happening, but that's the next project, I guess. So on this rig, so that takes me down to f5.56, 3 times the field of view or so there from the RC, 1.76 arc seconds per pixel. So that's a nice wide field rig, and it just rides on top of the RC. Okay. So then let's go to Planetary. So there's my Mars attempt. I'll keep trying, but that's what I've got so far. So we'll talk about the non-solar side of Planetary first. So, one of the things is planets are so small, and you're usually magging up so much that, your field of view is ridiculously small, and there's no ability to plate solve off that small FOV. So one of your challenges is, how are you going to get onto the target? So that's a common thing. And one of my approaches was a flip mirror, and it was sort of semi-successful. I added an Arduino and a bunch of 3D printed stuff so I could control it from in the house, and that all works. But sometimes, again, the optical length of it sometimes gets in the way, and I did end up deleting it from both for both the Mars, and this part of the same rig is used for solar, or not for solar, for spectroscopy as well. And I ended up deleting the flip mirror for that. But that's one way. And then the other way, which I've ended up using instead of the flip mirror, is I just use the other scope. So I put a camera on if I'm on the RC with the Planetary rig, I put a camera on the refractor and plate solve onto something from there, and then just use a spiral search in SharpCap to get onto the target with the smaller field of view. I do also have a set of dovetails that are adjustable so that you could align those two scopes perfectly. but that adds a lot of weight and a lot of angular. I don't know, PJ, what's the right word, but because it raises the refractor away from the center of the mount, it adds
Moment
quite
of
a
inertia.
yeah, it adds quite a bit. So I ended up deleting that as well, and now I just know that uh, if the refractor, if the object is centered on the refractor in the center of the frame, then it's actually going to be, down and over here or something. I can't look at my hands and get them right, but anyway, I know where it's going to show up in the where I need to move the object to be off center so that it will be centered in the other scope. So anyway, that's what I'm doing there. Um, so back to the requirements for planetary. So there's a rule of thumb that says that depending on the scene, you want to have some multiplier of your pixel size in microns, which is a kind of a unitless number, but that's the focal ratio that you want. So, if your pixel size was 10 microns, then you'd want 30 to 50 as a focal ratio. And yes, those are huge numbers. And I always tell the story that I learned when visiting Lick Observatory, and the nickel, I believe it's the nickel telescope, is a Cassegrain, and so they have three different configurations that they can do, which produce different f-stops. So they can put it where the secondary mirror would normally be for fast things, and then they can put it at the bottom in a full Cassegrain configuration, and then they can take the camera off and shine it on a mirror that goes down a hallway to the in the basement, and it's F39, and that's what they do for planetary. So because you want a lot of magnification. Um, and then another thing, if you're trying to image planets that are below about 50 degrees in altitude, you're probably going to want an atmospheric dispersion corrector. So those are some of the requirements. So what I came up with here, I ended up. I tried first. I tried the club has a Mac CAS, and I have a Mac CAS as well, but the club's was a little bigger. There was a 102. Mine's a 90. And those are like F12 or F13 native, so those are good for planetary, but they have a focuser that's like on an SCT. It's kind of hard to automate, but I did do that as well with the 3D printed parts and the Arduino and all that. But when it was all said and done, I didn't have enough really resolution, so I went back to the RC, even though RCs are not supposed to be super great for planetary because of their large center obstruction. It reduces the contrast. But anyway, so I'm on the 12-inch RC. I've got the atmospheric dispersion corrector here, which I have not yet learned to use, but it's it's there. That replaced the flip mirror. And then there's an adjustable Barlow. So this is the astrophysics. Uh, they have an acronym for it. I think it's like BARDV or something. The advanced Barlow, and it looks exactly like a CCD T67 focal reducer, uh, but it's a Barlow. And so you control the amount of magnification by how much space you have. Just like a focal reducer, you can control the amount of reduction. In this case, you can control the amount of magnification by the amount of space you have between it and the sensor. And it's 2 to 2.5 is really what this Barlow is good at. So I think I'm at 2.21 right now. And then for Mars, it was recommended that you use an IR bandpass filter for luminance. And I happen to have one of those that I was using when I was guiding from an external scope. So I wanted to add that to my filter wheel, but my filter wheel was 31 millimeters, and this is 1.25 inches. So I had to 3D print a little adapter that has the eyepiece threads on it for the 1.25". So that went in there. Took out my I normally have a light pollution filter as luminance there. Okay. Well, let's see. We talked about the Barlow with spacers, filter wheel. Right, and then you want a camera that's going to be as fast as possible in terms of frames per second. So just in the ZWO line, the one that's the fastest monochrome that they have right now is the ASI 174. So that's the one I was using. And then I picked up, this is a newer color camera that's even faster. I had gotten rid of my, or sold my ASI 1600 that was the color version, but I picked this up, which is even faster than the 174 one-shot color. So we'll try that and see how it works compared to. So I had to remove the IR filter in that case for that camera, but with the monochrome camera, of course, I was using luminance and then the RGB, or actually just R and B, and the G was synthetic, was recommended by the gentleman that I chose as my expert. The London Astronomer is his site. Okay, let's see. Yeah, so either pass-through filter or the one-shot color camera. So this rig puts me at f17 or 0.15 arc seconds per pixel, and this is in that rule of thumb for amateur scene of 3 to 5 times the pixel size, at least for the 174 focal ratio. Okay. Let's do some solar. This is my latest solar image. I managed to catch this sunspot just before it, in a moment of clear sky, just before it went around the edge. I saw it on space weather, and we're in a low spot of the 11-year cycle, so I really didn't want to miss this. But it was cloudy most days. But finally, I got a clear morning. So requirements for solar, if you've got a larger objective scope, kind of 80 millimeters or above, you're going to need to do something to knock out the amount of light entering. So you could either, just cut down on the opening by putting some kind of a mask, or you could get some kind of a filter. So you can just use a yellow or red photographic filter, which is what I did. I got a yellow one, but if you're going all out for the 12-inch SCT as a solar scope or something, then you've got a problem with. And people do sell SCTs completely customized for solar, but it's quite expensive. Just the energy rejection filter for that in itself is like $1,000 or something, I think. So it's crazy. So anyway, that's one thing you need. And then I'm using this camera quark. So I've got a separate slide on it, I think, but it's made up of, it's made to go on Canon lenses. So I don't know, you can kind of tell there's a Canon lens adapter there and another one here, and then I'm adapting it back to threaded connections for the scope. And I'm moving my mouse on the wrong picture here. So there's one here and Canon EOS mount here, and then I have other adapters added to convert that back to threads for astrophotography purposes. But it's designed for a Canon lens and a DSLR. But the point is, the two optical components here are, this is a telecentric Barlow, which is a particular type of Barlow that keeps all the light in parallel lines, and This is a 4.3x Barlow, and it's optimized for the HA bandwidth. And then this is the Etalon filter, which is the HA filter, and that's an oven with optical components in it, and you adjust the center frequency of that filter by adjusting the heat of the oven, or the temperature of the oven. So there's a knob here for that, and it's got I think 9 detents. So you click it however many detents you want, and then you wait 10 or 15 minutes for this light to turn green again from yellow, and then that tells you that you've reached the new temperature. So that's how the HA filter works on this particular unit. So we talked about the filter, and so then another problem that you have with solar scopes is Newton's rings, and it has to do with an interference pattern that sets up on the sensor, and the solution is to either tilt the camera ever so slightly, so the maybe 2 degrees, so the sensor it kills off the interference pattern. Or what I did was I bought a tilt prism, which does essentially the same thing, but optically rather than mechanically, and put that inside one of these. This is a ZWO Canon lens to T threads, and there's a 2-inch filter threads inside there, so you could put a 2-inch filter in there. And so I made again a 3D printed part where I could glue this tilt prism into that part, and then thread it into the 2-inch filter threads. So that got rid of my Newton's rings. So that the Newton's rings look like a Fresnel pattern, just a series of concentric rings. So you don't want that. So that's how I got rid of that. So
Pattern happens on any, like single, when you have just very narrow band light coming in, and you have 2 parallel pieces of glass, you get that,
yeah.
right? That's how that happens. So in theory, it would happen with regular astronomy too, and an HA filter, I guess. I'm not getting it, why we don't get it normally. Because I got it when I was taking, what do you call that, Northern Lights pictures, and they're a very specific frequency. But anyway,
Yeah.
I had a question.
Sure.
Another question for you is, why a Barlow? Isn't the sun big enough?
So you're trying, well, so it's this lucky imaging, so you're trying to ridiculously oversample, and there's formulas for what's the maximum detail that
It's lucky imaging. You
get.
mean you don't use one exposure for the sun?
Yeah, it's lucky. Yeah, it's
yeah,
planetary. You're taking video as fast as you can because it's
That's the
in and out of
ultimate
focus.
irony, right? You got the brightest object by far you could possibly shoot, and you're stacking it.
Yeah, so that image, let me back up here. If I click in here and then, yeah. So, whoops. So this was 30,000 frames, but I took the best 1%. So 300 frames. So this is a stack of 300 frames. So out of 30,000 frames that took, maybe I forget exactly how long it took, but it was much less than a minute. It was really fast. Because the area is so small, right? That's the other thing, is you're using a region of interest on your camera sensor. You're not using the whole thing, because again, you're trying to go as fast as you can. So reducing the amount of data that you have to transfer by reducing the region of interest lets you go faster and faster, right?
But I
So
guess it is like you're stacking, but you're not stacking to get rid of noise because, you know, you shouldn't have any with the sun, but you're stacking to somehow improve resolution.
yes, and what I learned, maybe it's obvious in hindsight, but when I was working on Mars for a couple weeks there, you know, at first I'm like, why is this guy I picked this guy as my expert, right? And followed his formula. And it's like, why is he taking 50% of his 3,000 in that case frames? Wouldn't, you know, 1% be better, be more in focus than the top 50%, right? Because that's what you're doing is picking out the ones that are more in focus, the sharper, right? But then what I learned is, okay, yes, the right out of the box after you stack, the 1% stack looks better, but when you go to sharpen it, you can't sharpen it nearly as much without artifacts. So when you go to 50% in that case, or you know, 300, a stack of 300 frames, you know, I'm not prepared to show you, but I mean, this is hugely sharpened. You know, none of that detail that you're looking at was hardly
So, Clay,
there. You know,
okay, one question is,
yeah,
if I understand what's going on, and please correct me if I'm wrong, what's happening is the atmosphere is sort of moving things around randomly at a fast rate.
yep,
And that's what's causing the blurring.
yep,
So you could shoot at a fast enough shutter speed, one picture would be better. So if you could shoot at 1,000th of a second or a 5,000th of a second, one picture should be sharper than a stack of 100, where you're trying your best to align, you know, to get lucky and have all those 100, you know, find the 100 that are sort of aligned. Wouldn't it be better to just take one fast picture? You got a bright object. Maybe you have to tune your, you know, your filtering so you don't burn up your camera. But
well,
I
I
think
think
that would be
that's
better.
analogous to what I was just saying. Was my finding was that when you did that, when you stacked fewer pictures, you know, I was talking about in that case Mars, 3,000 frames, and looking at 1% of them versus 50% of them in a stack. The initial result of the stacking looked better at 1%, but you couldn't hardly sharpen it without artifacts. Whereas going back to 50%, now you've got much more in the stack, so much more detail hidden there in the data. It was able to be sharpened quite a bit more. So
Okay.
that's
What I was talking
Okay,
about, though, you have to go down to 1,000th of a second.
yeah,
there's one point you're missing here. If you take
Okay.
a single picture of the sun, you are not only taking a picture of the sun, you're also taking a picture of the atmosphere, which has all these variation of waves across it. So in other words, a portion might be a little bit in focus, a very short distance away. It will be out of focus because of the different densities of the air that you're looking to and the heat currents and all that. When you're using a tremendous amount of stacking to do this, then those are going to end up with a somewhat blurry picture, but the sharpening algorithms will be able to treat that and average that out. You are looking to average out what you're seeing in order to find out what's real and what is the atmosphere. And that's the important fact of why you do stacking, to do all those things.
Well, I was hoping that if you shot, though, at a very quick speed, then you, whatever the atmospheric distortion is, it
will vary across the sun.
Okay.
If you do analysis, it's not a still picture. Everything is moving. Everything is moving, even in that shot. The very next one, the atmosphere will be different, and various portions will be more focused than others. You're looking through the atmosphere like you're looking through water that's got ripples in it, And depending on how much rippling, how much turbulence is going on, that's why you have to take a lot of shots so that you can average that. And then from that, be able to pull out with the sharpening algorithms, the detail that is real and be able to sharpen it. So you can take a picture, but it's not going to have much to do with the reality of the actual sun with just a single shot.
Yeah, single picture will be with very low signal to noise ratio. So basically, when we stack, we're trying to increase signal to noise ratio so much. Right? Otherwise, yes, you can take one image, but it will be very dark, right? And your signal will be very low, and you still have details, but it will be kind of.
It doesn't have to be dark if it's the sun. I mean, you have as much light as you want, as long as you're not burning up your camera. So my assumption was you could control it such that, you know, with 1,000th of a second exposure or a 5,000th, you could freeze it and you shouldn't have any signal to noise problems. Now, the atmospheric dispersion across the image argument, okay, maybe I'll buy that. But in terms of SNR, no, there's no reason. This thing is so bright, you know, as long as you don't burn up your camera, you shouldn't have any SNR problems. Anyway, I'm spouting off.
So two things. So we're taking as short an exposure as we can, such that we can do it in a stream, right? Do it continuously. I just had the folder open, so I can tell you. Whoops, wrong. This should tell me what. Let me drag this over here. So this is the actual video. So yeah, I was getting only 36 frames per second. So I don't know, without going deeper into the files, what the actual exposure time was, but it was, you know, milliseconds.
It's 36 frames a second. You sure it's not a 30th of a second?
I'm sure, yeah, because the limit here is due to the region of interest I chose to get more of the surrounding detail of the sunspot. If this was, you know, Mars or something, the region of interest would only be about this big, would only be like a quarter of it, and this camera can go at 150 frames per second in that case. But this is just limited by the speed of the amount of data and the speed of the interface between the camera and the computer. But anyway, you can see here all the roiling atmosphere. And the other point I wanted to make is it's not necessarily about signal to noise. It's about the detail that you can pull out with the sharpening. And again, that's why I wanted to show you. This is not very bright, but this is what the stacked 300 stacked frames looked like. And then I went from that to this with the wavelet sharpening, basically, and other Photoshop nonsense. So that's what I've learned so far about Planetary. Okay, let's see, where were we? Okay, yeah, so that's f30.32 arc seconds per pixel on the 12-inch, or no, on the 80 millimeter refractor. So we talked about the energy rejection filter. So this is, I forget, whatever, it's not 80 millimeters, but whatever the biggest yellow filter I could find was. And there's no filter threads on the refractor, so I made this 3D printed cover, which friction slides over the dew shield, and it has the filter threads that match this filter. And then it also was an opportunity to glue this little bracket on here for I have a solar scintillation monitor, which I didn't use for that particular image, but the idea is that there's a plug-in for fire capture. So this is essentially measuring the scene in real time of the sun, and then you could say you could just set it all up and let it run and say, well, start your image when the scene is this good. Right, so you could let it run for a couple hours as the sun moves over your lawn, which is the best, situation, unless you're up a couple floors. And it would just pick the best moments of scene to do, a 30,000 frame capture, and then you'd take the best of those kind of things. But I didn't have time to get that all going, and I just captured the data and went with it. But anyway, that's the energy rejection filter. Okay, and I need to move something on my recording here. Let me turn off my... Okay, so here's what the solar rig looks like on the scope. So you can see that energy rejection filter slid over the dew shield, and the solar scintillation monitor is there. There's also a solar finder, and have to put when you use a Barlow, it moves your focal plane out as opposed to in, like a focal reducer. So more space here between the scope and the focuser, and then the focuser and all the stuff we talked about that is the camera quark. This picture has the ASI 1600, but since then I've moved to the 174, which is much faster. Let's see, did we talk about everything? Yeah, the camera quark comes in two models. Mine is for the chromosphere versus the I always want to say flares, but that's not technically correct, right? The prominences. But I think most people buy the chromosphere because they're somewhat okay for prominences, and the prominence model is not as good for the surface detail of the sun. So that's a compromise that you can pick. Okay, and yeah, so yeah, I changed it to the ASI 174. Okay. To keep clicking in here to get the slide advance. Spectroscopy. So yet another thing you can do with light from objects in the sky. So this is just a slide from the talk I gave back in 2018, and I was trying to see if I could measure the redshift of a galaxy, I think it was, and this slide was about doing that measurement. Yeah, this is a galaxy UGC 545, and we're comparing this particular wavelength, which should be the same element, between Vega as a reference and what we saw in that galaxy, and then that gives you your redshift. So that's one of the things that you can do with spectroscopy. So as I mentioned, I think, or maybe it was before we started recording, in 2018, I had a star analyzer, which is a grading spectrograph. And since then, I've purchased but not used until this last weekend a GRISM spectrograph, which is a combination of a prism and grading, and we'll talk about that in a minute. So going back to the format of requirements and the instrument package, again, you're going to, since you may not be able to see the actual stars once you've got your spectrograph in place, or spectroscope, you're going to need some way to get your target on the image, and also, I guess, if you wanted to guide, then you'd have to have a way to guide as well. similar to to Planetary, you're going to want a higher focal ratio, and that gives you a less critical focus zone. So you can think of it like a depth of field in a terrestrial camera, right? You have a higher f-stop, you have more depth of field, and so that makes it easier to focus and get the critical sharp detail you need to see those lines in the spectrum. So there's various types of spectroscopes, the grating, the prism, slit, and then there's combinations of all of the above. Um, so this particular instrument package, and you see I dropped all the way back to a Canon T3 here, although I'll be changing this to a ASI 1600. I wasn't sure that the spectrum would fit because this particular rig was, excuse me, designed specifically for a DSLR crop sensor sensor size. So yeah, so I'm doing this on the William Optics refractor. So again, it's that adjustable Barlow from the Planetary rig, and this is why I wanted to take pictures and document all these different things so that if I'm moving things around, I can get back to where I was if I want to go back and do Planetary and take this apart, right? So there's a grism here inside this. There's a T-ring and a nose piece here, and the grism is in the nose piece, and it's fixed in terms of its optical distance from the camera sensor. And then there's a thumb screw here so that you can adjust the angle of the spectrum so that it's along the horizontal axis of your sensor. Yeah, so the adjustable Barlow, the grism, and then the guy that sold the grism included this star diagonal with an eyepiece, and the eyepiece is fixed in here with grub screws at a particular setting. So the idea is that this exactly matches, you know, the optical distance here between the grism and the sensor. So now you've got the optical distance between the grism and the focus point of the eyepiece, so that when you look in this thing, you know, you remove the camera and actually the grism actually, and then put this eyepiece and diagonal in there, and then you could use that to focus, and then take that out and put the grism and camera back in, and you should be precisely in focus. So that's one approach. Okay, and so here are the two types of spectroscopes that I have. This is the star analyzer grating. It's about $200, and then this grism thing was about $325 off of Cloudy Nights. And then the next step up, unless you're going to make your own, is like $3,000, I think, in spectroscope. So there's a big gap there. I did see one guy that's got a nice 3D printed design for, which would be on par with like the $3,000 spectroscopes, but he thinks you're going to spend about 600 euros to in optical parts and all the printing and stuff to get to that level. So I don't know if I'll go there, but we'll see. Since I'm 3D printing, but we'll see. So this is how the grism works. So the grating is actually on the diagonal of the prism here, and that's mounted inside this T adapter nose piece here, and then, you know, it goes and puts the spectrum on the sensor. And the reason for this over just the grating by itself is without the prism, the focal plane of the spectrum is actually curved, right? So maybe, whoops, sorry. Maybe it's perfectly in focus in the red, but then as you get over towards the blue, right, the focal plane, it should be up here, and so the blue will be out of focus. So this prism is supposed to fix that. Now, one thing I've noticed is that with the grading, you normally have the actual image of the star and then its spectrum off to the side, and that when you go to calibrate your spectrum, that's convenient to know that the star is the quote 0 point, and then you can count pixels over to an H beta line or something and calibrate that way. But with this particular setup, it looks like you don't get a star image at all. So it's going to be a little bit more complicated to calibrate. You'll have to identify two lines in the Balmer series or something, where you have dips in your spectrum to get calibrated.
How do you even know which star you're taking a spectrum of?
Yeah, so what I found, so previously with the grading, right? And it just depends on the star field you're looking at, but you get your star that you want centered, right? And so then you can identify that star and just look at that spectrum from that star. And if there's other stars that are causing overlapping spectra, then you can create some kind of mask or something. In the case of the GRISM, what I found was maybe just because of the targets that I chose, and I tried to take data from 8 or 9 different things on Saturday or Sunday, I think it was. But it seemed like there was only one bright spectrum, and again, you remember when I said that I knew if I plate solved on one scope, I knew where in the other scope the image would be, the actual image would come up, right? So the spectrum that I wanted was starting at that location on the sensor that said that that's the object that I centered with plate solving in the other scope. I hope that makes sense. So far it hasn't been a problem, basically.
Okay, does this work with, can you get absorption lines from Nebula, or is this not?
Yeah, there's some, I wasn't prepared to do a whole spectroscopy talk tonight, but I can recommend, so watch the YouTube that Tom Field did, the speaker talk after the board meeting last time. And he recommended this book. Let's see if I can. Astronomical Spectroscopy for Amateurs by Ken Harrison, who I've been emailing with all week. So there's a lot of good information in that book. And he talks in great detail about, how you would go about getting absorption lines from a nebula versus a point source like a star or a planet. He talks about, one of the chapters is, here's some beginning projects, right? So he talks about looking at the methane lines from the atmospheres of Uranus, Neptune, and I forget what the other one was, but anyway, I went and took data on Uranus, and I haven't analyzed it yet, but this is the first data that I got from the GRISM. So you always want to start with Vega as your example, and then you bring up these hydrogen Balmer lines and try to line them up with the dips in your spectra, and then and here there is this spike here that I think might represent the 0 point or the star. So, but I need to basically I need to go back, and I learned a lot since I took this data, and Ken has been helping me, as I mentioned, the author of this book. So basically I underexposed the data. I was being too cautious to make sure I didn't overexpose it, and as a result I underexposed it. So I need to go back and retake the data because I think he was explaining to me, this dip right here is actually an artifact of the Canon Bayer matrix on basically all their cameras, and so it's not really a valid dip in the spectrum there. So I probably didn't do these lines correctly, even though it looks like it's correct. So anyway, some learning there, but you know, comparing the two, the GRISM, you know, this is you have a resolution of about 14.8 angstroms, and with the star analyzer, you know, it's 33 angstroms, so it's not quite as precise. This is data from the star analyzer back in 2018, and the reason there's this big hole here is because I took it through a light pollution filter, right? So there's a big hole cut out where all the man-made light would be. But so this is a synthetic spectrum, colors mapped in here to the spectrum profile, and this blue line is the Vega spectrum. Okay. Other bits. So as long as I was documenting everything, let me turn off my other camera here for a second for the recording. So yeah, the flip mirror, and I threw out an off-axis guider that I have as well, so you guys know what those are. Okay. So here's my astrophotographer joke. So, you know, I put all this crap on the scope, which was really long, and then I went in the house and had it slew to target, and then I came back out and it's like, oh, I almost hit the fence. So yeah, you might want to think about that if you're putting all these spacers on things. So I moved the scope further up and rebalanced everything to get a little more clearance there, because that was a little too close for comfort there. Okay. So now it's time for Gemma's questions. You got questions? Okay, no questions. All right. Okay, Bruce, where do we go from here? I have a couple other things I could mention, but let's give somebody else a chance to speak here. Let me turn off my presentation.
I have
Paul here. I have a picture that I can show.
That sounds good, PJ. Let's see what you got.
Yeah, let me see if I can figure out how to do this. Present now. Yes. All right. Now that the fires have gone away, they finally admitted that the creek fire has stopped growing today. Since I've had about 2 months of not being able to do any pictures, I had to kind of remember how to try and do things. Ha! So I been tuning things back up with my 11-inch Raza and the mount and the guiding and the this and all that stuff. So finally, I did do something more or less right. So I have this. This is the Perseus galaxy cluster.
You're not presenting.
Yeah,
We don't
PJ,
see you,
am I not?
PJ.
down in the bottom
Whoops.
right, see if you can click on present now, and we'll see your screen.
Oh, okay. Hang on a second. Present now. Here we go. Present my entire screen. That work? Okay, I want to share this, I guess, huh? Okay.
That's correct.
Oh. So when I go here, do you see it?
We're not seeing you present yet. No.
think there's
Oh.
one more click. You pick entire screen, and then there's an OK at the bottom of that dialog.
Okay, Chrome wants to choose what you'd like to share. Let's try this. Okay, I share that.
There we go.
Here it
Oh,
comes.
hey,
Okay.
hey, wonders never cease. So, I've got this.
Wow.
Hang on. Now I get rid of that. Oh, there we go. We'll do this. Okay, so this is, I took the data for this night before last, and this is 80 minutes of data with the Raza, 80 exposures, 1 minute apiece. And this is in Perseus, and this is one of the most massive galaxy clusters that we know about. It's 240 million light years away, give or take. And it also contains, well, I have my cursor here. This is known as Perseus A, which is evidently the brightest X-ray source in the heavens that we can see. And in this picture are about 1,000 galaxies. So this is kind of like an interesting thing that I've observed over the year. First of all, I observed this visually with my 18-inch a number of times. Well, quite a few times actually. And it was always kind of fun to see where I could point the telescope and count how many galaxies I could see in a single field of view. So I got up to about 25 or so when I lost count. So this is what you call a one-to-one view. And as you can see, many of these galaxies are ellipticals, some lenticulars, not too many spiral galaxies. I'm afraid they've probably gotten all eaten. And there are many, there's a lot of absorption from our galaxy and of course in intergalactic space. So all these galaxies have been quite reddened. So I was able to bring out the found stars and give them a little bit of blue color just to get some stuff to it. So this is the way the Raza works out with this one with the 268C, the QHY is these are 1.77 arc seconds per pixel. When I bend these 1.5 to 1. Seeing wasn't that great, but and a lot better than it has been. This is kind of what I was able to do with this with just 80 minutes of work. That being said, I had to throw away about 50 photos because at this point, I have not been able to figure out how to dither with sharp cap. And so I brought up my old Canon and had it run a random dither every about third shot and then just threw out the ones that got doubled. So what can I say? I'm a bit of a carpenter. Can't figure out this computer programming stuff that well. So
why did you throw out the ones that were duplicates of the drizzle position?
Well, because each star was doubled. You know, it dithers during the middle of an exposure. So therefore, you know, each star gets doubled or, you know, trailed or whatever you want to call it. So then out of that, I rejected about another 10 just using analysis and picks insight for exposures. So it would be nice that if I could tame sharp cap, but at this point, it doesn't seem to be happening too much. The program, frankly, is kind of like a little bit complicated to do what I want it to do. And it's a common issue. I can't figure things out, but I make do. So, any questions with this picture here?
No, I think that you can use a dithering setting in SharpCap when you're doing live stacking. You just have to connect it to PhD through SharpCap. And
yeah, I have seen that, but I haven't been able to get. I don't really prefer to do live stacking. In a way, I'm sort of a manual, hands-on kind of guy, and I want to be able to inspect every photo that I take and decide.
I understand.
Yes.
But
so if I had to have to deconvolute that stuff in order to do that, you see.
Yes, of course, PJ. But if you do a live stack, you can discard the live stack. You don't have to keep it, and you can have it keep each of the individual fit files that you save.
Yeah.
But at the same time, if you do it using the live stack option or subroutine, whatever you'd call it, in SharpCap, then you can do dithering using SharpCap, and it will dither between frames instead of during frames. So you won't waste as many frames, and you should have a lot more data.
You're going off, Bruce. I don't know why. Yeah, well, maybe figure it out someday, and then when this COVID stuff is over, maybe I can have somebody come up here and show me how it's done.
Okay.
That's kind of an invitation to come up to the stairs and
that sounds like fun.
Yeah. So
hopefully we'll all be able to do things like that soon. Maybe by the summer if we're lucky.
Okay. Well, that's about all I've got to do. Data that I can now run through and see how I can do on it. So that's what I get to do when the moon gets into the sky.
Thank you very
Everybody
much.
else do lately.
Does anybody have any images that they want to share? Francesca, you've done some stuff recently down in Pinnacles, I understand.
We're looking at specifically one county that is part of
If you want, I can
quickly
quickly show it.
along partisan
Sure.
lines not to certify.
Absolutely.
Can I take the presentation, PJ?
I've gone off.
Let's try. All right. So this is PJ's image, which I was looking at on AstroBeam. Now this is the picture I captured last Saturday from Pinnacles West. It's IC 342, the hidden galaxy. Very much like the Perseus cluster that PJ was showing. This one also sits perspectively relatively close to the Milky Way. So there's lots of absorption of the light and reddening of the light from the dust in our galaxy. And so the galaxy is always also sits in the middle of a dense star field, so it's hidden. And so that's where the name comes from, by a curtain of stars that I tried to render here without doing my usual star reduction, so that you can see the density of the star field and the colors. If I zoom in, the galaxy still has a very nice spiral shape. You can see some interesting dust lanes, some H2 regions, in the galaxy. And for me, this image is also interesting because it's the first one that I captured using automation. If you know how I image, I always kept a very low-tech approach. Keep it simple with basically without using a computer for acquisition. I have a standalone autoguider. I have a standalone focusing system, and I use a DSLR. So I just program the sequence in the guider, and I let it run. With the disadvantage that I have, it's not really unattended. I have to do meridian flips myself manually. I don't have any plate solving, so framing is always a little bit complicated. But this time I decided to try something completely new for me, which is to use a program called NINA, Nighttime Imaging and Astronomy, to orchestrate the entire capture sequence. So I programmed NINA in such a way that it waited for night to fall. It started taking pictures. Before taking picture, it slew to the object, plate solved, gave me indication on how to rotate it, started the guiding, and took the pictures, dithering, and doing a meridian flip. And it's more complicated, of course, than my keep it simple approach. And so maybe I wouldn't have started with my astroimaging journey if I had to overcome those obstacles right off the bat. But at this point, I think I see the advantage. Not so much from a dark site at Pinnacles, but from home. This allows me to capture all night while I'm sleeping, which I know that it's nothing new for you, but to me, this was a big improvement in my workflow. And the interesting part is that I didn't, the application, one of the reasons why I was so stubborn in not embracing automation is that some of my hardware, in particular my guider, is not supported by most of automation software, because it's not really a camera, it's a guiding system. It's the equivalent of a PhD2 plus a camera, not of a camera itself. So Nina had some form of rudimentary support for that, and I managed to, given that it's open source, I could modify the code myself to add the full support, and yeah, it works. It's I'm rather impressed. I don't know if I switch to my, can you see my screen, my Nina screen in this moment?
Yes.
Yes.
Yeah.
Yes,
So
we
this
can.
is the UI of the program. This is the sequence that I used to capture IC342. You see, I tell the program wait until night falls, then slew to the object. Right now it gives me this red sign because it's not the telescope is not connected. Center and rotate, start guiding, run autofocus, and then start taking it. Honoring a meridian flip is needed. Refocusing if the HFR increases above 5%, and then capture 45 pictures, each of them 480 seconds. With my, well, this is a DSLR, so binning and gain are default values, and offset the same. Doing a dithering every time. And once this is done, I actually, while I was at Pinnacles at that point, I added another sequence right after this one to capture another object, which is this object here that you can see here in PixInsight. It's very much a work in progress. This would require much more integration time. This is only 3 hours. It's this nebula here is NGC 2182, and this is in the constellation Monoceros. I found this nebula particularly intriguing because of all these dark dust lanes that you can see here.
It's called the Angel, right?
Somebody called it the Angel Nebula, but after Rogelio imaged I can't remember the name, but he imaged an image which is part of the IFN that he calls the Angel Nebula, and I think that the name stuck, and so I think the Rogelio's Angel has superseded this one. But yeah, I agree with you. I heard it called with his name. It is extremely faint. It takes it requires a lot of way more integration time than I gave, probably 10 to 12 hours. This is only 3, and has some nasty reflections from Gamma Monocerotis and from another star that I couldn't identify yet. But yeah, if the weather cooperates and the COVID lets us go out of the county still in December and January, maybe I'll be able to integrate more data. Now, the nice part with Nina is that I can use plate solving to go exactly to the same point at the same orientation. So it's going to be much easier than I used to be comfortable with in the past.
That's a game changer, isn't it?
Yeah, it is. It's a big improvement.
Especially if you want to get back to the same image that the same location that you were at another night, you can just plate solve one of your prior images.
Yeah, the plate solving is a huge improvement. The other one, well, meridian flip, of course, if you want to do unattended imaging. The other thing that really impressed me is the autofocusing. So I was using basically I have a focusing system, motorized focusing, that does a form of dead reckoning. It measures the temperature and has a calibration curve that knows how many steps the focuser needs to be moved inwards per each Celsius degree of dropping temperature. But of course, there's no. It's an open feedback system. It's you never know until the sequence is done and you're looking at the images. By using this Nina or other softwares that can support autofocusing, using the main camera as the detector for focusing, it's all the guesswork is gone. You have a very nice V curve, and it determines the best focus point, and it constantly monitors the HFR during the night. And so if something changes, then it can trigger refocusing. In the case of my imaging experience at Pinnacles, when the HFR degraded, unfortunately, it was because of dew and not because of refocusing. So that spelled the end of the night for me. But yeah, that was a very fun experience.
So some of us that have tried Nina in the past saw a lack of scheduling flexibility. Has that been addressed yet, or?
Yeah, so let me go back to my Windows terminal so I can show you. So this is what they call the advanced scheduler. You can have conditions like wait for time, wait until the object has reached a certain altitude, and when the altitude goes below a certain threshold, you can schedule. Of course, I'm using OSC, but if you have a monochrome camera with filters, you can decide to do only certain filters depending on the night. I'm not sure. I unfortunately I don't have any other experience with the things like SG Pro, so I don't exactly know what to look for. But if you can give me examples, I can find out what's available. This is what they call the advanced scheduler. There's also an easier scheduler that has fewer options. So for instance, you cannot set those conditions like wait until the object has cleared a certain altitude and so on.
Okay.
And it's all drag and drop. These are the various verbs that you can add to the program, so to speak. And for instance, you wanted to program in such a way that at the end of the sequence, the scope is parked. You just drag this where in the sequence you want it, and it's there. And it will be executed after the sequence in this case.
Voyager, which is another sequencing program, or in general astrophotography program for capture, has something called drag script, and I believe it works in a similar way, dragging things in order for each thing that you want to do.
Yeah,
I haven't used that aspect of it, but it's a pretty powerful way of doing things, I understand.
one of the things that's also interesting, in addition to being open source, has a plugin architecture. So people can, in theory, develop a plugin for the sequencer. For instance, they don't use a forum, they use an app called the Discord. There was a discussion there. Somebody was suggesting implying that he would like to write a plugin that lets you sample the local horizon and lets Nina decide that, well, I can only image this object after has cleared the obstructions in the local horizon. And so it takes care of that for you.
Wow.
I haven't seen it yet. It was only vaporware.
Sounds like a great idea, though.
Yeah. All right.
Okay, thanks, Francesco.
I'll give back the presentation.
Anybody else have any recent images or adventures they want to share?
I wanted to ask, I have an image, but not a star image, but related. Before I do that, I saw an old, I don't know, probably August email from PixInsight that mentioned that they had introduced a feature called integration with the Gaia DR2 database, star database. If you folks saw that. And so, you know, basically, if you're not familiar with that, that's a star survey, right? That some satellite did where they, I don't know, I think they got like 500 million stars, detail of that, right? The positions, the proper motion, the colors, luminosities, etc. Probably tags like if it's a variable and not of a whole bunch of stars. It doesn't look like it's really integrated yet with many PixInsight tools, other than I believe their solver. But that would be interesting, right? To take your image and play with it and point at a particular star and get details about it. But anyway, as far as I could tell, and I did send an email to Rob, who seemed to indicate that it wasn't doing that yet. But anyway, they allowed for the ability to do that for people who write plugins, I guess, for PixInsight, and who knows, perhaps one whatever his last name is, will do that, right? So that's interesting. But anyway, that got me interested in this Gaia database, which one can access anyway. Just via Python. So I did this one little thing I'll show you about, since I'm taking these astronomy classes, and everybody, in every class talks about HR diagrams and, this and that about the HR diagram. So I solved one of my images and dumped just, into a text file, the RA and DEC positions and radii of all the stars that I solved in the image. And then, here, let me share the screen for a second.
Is this through AstroPy or
Is what through AstroPy?
Your Python? Are you using AstroPy or some other package, or you just?
Oh, to access Gaia?
Yeah.
I believe so. I believe it was an AstroPy. But any event, so. So you can see that HR diagram there? Can people see it? Oh, good. So this is cheating. This is the first step, but what this is the start. I took an image of mine at M13 of M13. The reason I took M13 is I didn't want any nebulas, like coloring the image, changing the colors of things. I don't know. So, most of my images have big red things all over the place, and I figured that would sort of change the HR diagram. So I took something that didn't have that. PJ's image clearly would have worked too, although those would have been galaxies, so that's a whole different story. And I, anyway, but I took the detections, but then all I did was, given my RAs and DECs, queried Gaia for their for the color and for the effective for the color, and for the absolute luminosities. And then that's what an HR diagram is, right? It's a log plot of temperature and absolute luminosity. So anyway, but here you do see a nice HR diagram with, there's your red giant part, and there's your main sequence, and cut off here, maybe because I don't know why, either because it really is M13. The picture was much broader than M13, and maybe M13 does stop there because of its age, or who knows why I'm missing brighter stars. But anyway, maybe they're all saturated or something like that. Who knows? But I'm going to stop sharing and give you a little more detail about my plan and then end. So did I stop sharing?
Yes.
Okay.
Yep.
But I cheated, right? Because I used Gaia data. And so then the next plan is to just sample the pixels off of my image that I did the star detection on, and, get the color from, R minus, blue minus red, and try to get the absolute luminosities by the pixel values normalized. I'd use the Gaia. Gaia gives you the parallax value, so you can compute the distance to all the stars. And so maybe the pixel values normalized by the distance squared, and see if I can make myself an HR diagram like's in the textbook. But anyway, that was my little project.
Are you familiar with Astro Image J?
No.
I would think that it would do most of what you were talking about, but I could be wrong. I don't pretend to understand all the photometric stuff that it does, but that's what it's for.
Oh, cool. I mean,
Yeah.
the point for me is to do it, right?
Yeah, no, I get that.
But yeah. But anyway, Gaia is an interesting resource too.
Yeah.
It's
Well,
2 lines of Python to get information about any star.
And I was going to say that sort of the long way around to do what you were talking about, where you could click in your image and get data, you can put your image in Stellarium and it overlays accurately the stars that are there. So you could then click on a star and Stellarium would tell you all the details about the star.
So for my project, the important piece of I'm sort of starting with the HR off of Gaia,
Yeah.
to see where I screw up, right?
Yeah.
Data processing, but my goal is to be able to get it off of my telescope. But I'll always need, I believe, the Gaia parallax. How far the star is, right? Because if you use apparent luminosity, that's a different HR diagram, but it's not quite the same. But you really want the star's absolute luminosity, how bright it really is, and for that you need the distance. So I'll always be bugging Gaia for the distance. But okay.
Yeah, take a look at Astro Image J just to see what it does and how it does things, and that might give you some hints.
Okay. Thank you.
Also, PixInsight has a script for aperture photometry.
Yeah.
So it integrates the fluxes for you.
Okay, so it would give me the fluxes.
Yeah.
K-Stars does that too, so I can do that. But K-Stars doesn't do it in a way that the end user can get at. But since I can get at it, and I'm writing this code anyway, But okay, thank you.
And there is another software called Astrometric, which actually performs photometry for multiple stars.
Astrometrica?
Yeah, it's very often used for detection of supernova and also for hunting asteroids and hunting comets.
Okay.
So basically, you have to take a series of fit files and drop it into Astrometrica, and it has actually a full automation to detect new objects on the images.
So it sort of detects the stars and sees what's moved?
Yeah.
That kind of thing?
Yeah.
Or sees if there's some, these kind of, by the way, I learned something, right? I never knew what magnitude stars I could image, right, with my telescope.
Yeah,
I mean,
because
I think-
I use Astrometric J to detect things, but it's very manual. And real astronomers, they use it. They don't use Astrometric J because they when they try to detect something like supernova, they scan really big parts of the sky per night, and it's fully automated. So basically, they have a fully automation to detect what is new on the images
Uh-huh.
immediately, right, and send to the email. It's Astrometric is the closest thing I could actually think is available to that.
Okay, cool.
Yeah.
Anyway, I look at these things.
Yeah.
Yeah, and there's a lot of stuff in AstroPy and probably some other Python packages as well to access all these databases and stuff. I'm using parts of it to do the Stellarium image stuff in my rudimentary Python scripting that I've done.
Well, anyway, if anybody wants my script for getting the Gaia DR2 stuff, and I guess DR3, I guess is just an improvement on that. It's coming out in December. But it does give you a wide variety of information pretty easily on given a RA and deck.
By the way, again on Stellarium, sorry, I'm stuck on that planetarium versus others, but I recently learned that you can bring in sky surveys, so you can turn off the nebula images that we've put in and show instead, a DSS survey or something. So you can, even if there's not a nebula image there, you can get an actual picture of that area of the sky to kind of see what framing you might want to use and stuff. So it's kind of handy.
Yeah, what's the name of that? There's a website that I use that I like. You guys probably know about it, WikiSky.
That's one I haven't heard of.
That's really cool. Check it out.
Okay.
Just wikisky.org. It does just what you're saying.
Okay.
So that's how I frame.
Okay. Yeah, the framing in Mosaic Wizard in SGP is nice that way, and then you can put in the name of an object, and it'll go get a DSS survey for whatever degree size you tell it, or you can give it an astrobin URL, and it'll figure out where that is in the sky and pull in that sky survey, or you can put in, RA and deck, and then you can draw. If you're doing a mosaic, I just use it mostly just for single frames to figure out how I want to rotate the camera, right? And how I want to position, the framing basically. But you can also, just draw a rectangle and it'll say, well, that's, 4x4 or 5x8 or whatever mosaic. So you can compose your mosaic that way too. So that's a pretty cool feature.
Glenn, would you say again the name of that tool?
It's in Sequence Generator Pro, and I've lost track of the different flavors they sell, but it's in the higher end version of what they sell, and it's on the tools menu, I believe, Framing and Mosaic Wizard.
Yeah, it's included in the the paid version as a standard thing for Sequence Generator Pro these days. By the way, I understand they're going to be coming out with a version 4 of Sequence Generator Pro soon. Exactly what the differences will be, I don't know yet, but hopefully it'll be some good stuff. Anybody else have anything they wanted to show us tonight? I was actually wondering if maybe Francesco has an idea. Have you, you probably haven't upgraded to the new Mac OS yet, I guess.
Oh, I'm lagging behind. I'm still with Mojave.
Uh-huh. Well, you're sticking with what works, and that's.
I have some 32-bit software that I needed to continue using it, so I cannot even go to Catalina.
Got it. Okay.
Yeah, I was telling Bruce before that I'm stuck on High Sierra. I can't move from that until without spending a lot of money on some software that I let go out of support.
Yep. I have the same problem.
Yeah.
But what was your
Okay.
question, Bruce?
PixInsight.
The new version, probably not.
PixInsight doesn't work
Maybe
with
using. I don't know if it would work with the new, the Big Sur version. That's what I was wondering. I mean, we have had issues in the past where things changed, and then PixInsight didn't work with the newer version. So I was just wondering if anybody had any input on that. I'm not planning on upgrading anytime soon. I think there are probably a lot of growing pains that have to be worked out with the new Mac OS, but it looks interesting.
Yeah, I haven't even looked at the forums to see if anybody has tested it. I'm doing it right now.
Okay.
Did people see the Telescope Live launch their 2.0 platform? I got a lot of emails from them because I had bought some time, but I didn't know if people in general knew about it. Okay, crickets.
Yeah, I got also invitation
Okay.
for that. Recently, actually, one of my images got actually top pick. That's Astro Beam. It was actually from Deep Sky. What was that? There's another online telescope array in Arizona. What was that?
Deep Sky West.
Deep Sky West, yes. And I didn't know until yesterday that the image actually is a top pick. I opened my Astro Beam and saw, oh, I have a top pick. It is of a nebula. Let's show that. Let's see. Log in. Yeah, it's actually LDN 1622.
You're not sharing.
Yeah, just a second. Yeah. Okay. All right. Can you see my screen?
Yep.
Yes.
All right. Yeah. So that's the image. It's actually a nebula in Orion.
Oh, beautiful.
Yeah. So I saw the advertisement. You see on the right, there are a bunch of advertisements.
Wow.
And I saw Deep Sky West. And they have 4 sets of data. And what I like most on this image is that I was able to see this kind of white area here of the nebula surrounding the dark side, dark patches of dust, right? There were actually more people actually trying to actually process this data, but so far this image is one of the few that actually you can see this halo kind of structure around.
Cool.
Yeah, but it's there.
Congratulations.
Yeah, thank you. So, yeah, I'm imaging tonight as well from a telescope.
Well,
very nicely done.
I think that arrow icon, because I saw that pop up on a bunch of images. If you hover, I think it's, I don't want to rain on your parade here, but I think it says you're nominated for a top pick.
Yeah,
Yeah,
that's
nominated.
correct.
Yeah. That's
Nomination.
a new, they didn't have that exposed before. Now they're exposing the nominations.
Nomination,
Yeah.
yeah.
But still, beautiful image. Yeah, congrats.
Beautiful.
Thank
Image.
you.
Yeah.
I think that's known as the Boogeyman Nebula. Actually.
Yep.
Cool.
Yeah, thank you so much. So
Yeah.
All right.
Yeah,
Please go ahead.
so say a few words about Telescope Live. I mean, you'd have to read through all the stuff, but they're trying to monetize and in some ways I'm a little upset. It's like they're trying to take over AstroBin. It's like they're trying to be the place where people post their image and the social interaction and all that. So maybe competition is good, but I feel a little bit like it's going to dilute the community some, but um, and then they're offering what they're calling pro data sets. So they will, take us maybe 4 images in a month and give you the calibrated subs as part of your subscription. And I think it's like $50 a month is the level at which you have to subscribe to get that. And you get a certain amount of telescope time. And they have a very, if you've used like itelescope.net, they have a very different approach. It's more automated where you just put in a request. It's like, well, yeah, I want to use this particular telescope in Chile and I want this many HA, whatever, but you don't go and pick date and time in a schedule, right? They just manage all that for you and then they'll come back and say, okay, well, you wanted that stuff and we think it'll be done on November 30th and check back with us and see if it's done or not kind of thing. So it's a little more removed and you don't get to log in and see the actual thing in progress like you do on with ACP, modified ACP on itelescope.net. But it's interesting. They have a very slick interface and it's very app-like and modern and all that. So we'll see. It's some interesting pricing structures too, but it's something to check out. There's also, I think, for $9 a month, you get a certain amount of telescope time, and you get they send you. You say, well, I'd like M31, and they'll just send you a picture of M31 that was gathered at some point. So I don't know. You got to read through the emails. I mean, I can forward them to the SJAA group if you want to check it out, or just go to telescope.live and I'm sure you'll see all the advertising. Let's see. Let me put in one plug for something I think SJAA would be a good thing to do, would be to have a program around citizen science. So we talked a little bit about spectroscopy, that thing with the light and the prisms. We talked a little about that, and we talked a little about photometry tonight. And we've had talks in the past. The high school did the radio telescope project, and we had going back a couple years, we had the high school twins that did the exoplanet search and wrote software for NASA and all that stuff. So I don't want to do it myself, but I'd really like it if somebody would launch a program around citizen science, because I think there's, well, and another, so I have this camera that tracks fireballs that SETI consumes the data and all that. So that's another example, right? So there's lots of different things that elements of astronomy or corners of astronomy that you can get involved in and do sort of pro amateur, do real science, right? And help the pro astronomers do their job and stuff. So it would be interesting if somebody would volunteer to drive that. So I just thought I'd throw that out there.
Well, I'm interested to some extent.
Cool.
Yeah, but we can actually discuss.
Okay. Yeah.
Because I have been in touch with professional astronomers and I provide some data to them back in time. And there are different aspects. We can actually
Right.
talk what exactly can be presented. And actually, it's very nice to everybody because sometimes we take subs and feed files and data, and all of a sudden, actually, I found an asteroid on the image. Yeah, and I didn't know actually it's an asteroid until I actually did the stack. I found something is moving, and then I sent to astronomers, and they say, "Oh, we know this asteroid. Don't worry." So, all right.
I saw something when I was taking my spectroscopy. There, I said it. Data on Saturday or Sunday, and I went back to look for it the next night, and it wasn't there. So I don't know if it's. I'm trying to bring it up here. If it was just a cloud, but it looked like a nebula where there shouldn't be a nebula. Let me try to find it here. Terabytes of data. Oh, let me try another way here. Yeah, it looked kind of like the Veil nebula, kind of like a shock wave. But then, like I said, I went back the next night and hit it with full-on deep space versus just a plate sol frame. HA and S2 and all that, O3, and there was nothing. So I don't know what the heck that thing was. Oh man, where did I stick that data? Well, I know another place. It's on my Google Drive. Okay, let me present here. Share. Yeah, so I don't know what that thing is.
It's a reflection.
Is it? Okay. Because it wasn't there the next night. So it's a reflection from something bright off the screen. Is that off the target?
Yeah, and probably very close. Is it possible that something like a street lamp?
Yeah. No, my neighbor has a light that shines directly on the telescope. It's so stupid.
Awesome.
Yeah, well, I put up a wall, but it's still not enough. But
It's too perfect to be nebula.
yeah, I thought maybe I discovered something new. Yeah. Yeah, that's just a plate saw frame, but anyway, yeah. Okay. Well, problem solved. It's not an alien attack or anything, so it's all good.
Not this time.
Yeah, not this time. We'll keep looking. Paulo, you mentioned doing something with Nina too. Are you hacking Nina, or are you just working on the OCS software to make it talk to Nina?
No, in this moment I'm talking. I'm using K-Star.
Okay.
It's
K-Stars.
Yeah, I'm using K-Star in this moment, and I was using Nina. I tried Nina a few months ago, but I stopped for the lack of scheduling.
Yeah.
Because with my small keyhole to the sky, I need to have more job on the same night in order to have a decent number of data collected. Otherwise, I have only 2 hour or 1/2 hour for each target. But now I see from Francesco's presentation before that also Nina's starting to have a scheduler in order to have the possibility to have a more job
Yep.
one after the other. So maybe I will look at that. You know, I decided to run away from SGP, so I'm in search of alternative. So far the K-star is good. I just today I solved some problem of connectivity with the Raspberry and the hardware, because you know using a hub is always a problem of assignment of the USB port, and they can continue to change this and the other. That's the problem. But yeah, probably I will, due to the fact that and another problem was that for Nina that the Astromechanic Canon focuser, the one from Russia, they were not having the Indy driver. And so that was precluding both Nina and K-Star. But since a couple of months ago, they have that, so that's another good option. And I'm using that that focuser from Astromechanics, and it's working very well.
Good. Yeah. Well, the whole observatory control system is a topic that I think you and I should, or one of us, I can volunteer you, could present on. People are probably tired of hearing from me, but that's another thing that you know we've been working on during the COVID thing. So even though we don't have observatories, it's kind of nice to have all the weather sensors telling you what's going on.
Yeah, and that was my and is my next project, because I connected the weather, let's say, and the SQM sensor that more or less we made in parallel to SGP, but now I'm moving all the hardware to an Indy environment, and well, I don't know when it will be ready, but the near future, I hope.
Maybe Hai could help with that part of it.
Yeah.
The guy.
I'm trying to mimic existing hardware.
Oh, okay.
For weather in the Arduino part. So.
Okay, that's another approach. Yeah. Hai, were you saying something?
No, Hai left.
Oh, yeah, Hai left. Okay. Well, that's we can give him the action items then. Yeah. So these are there's a whole I don't know if I've mentioned this before. This observatory control system. There's a whole forum and everything, and this guy has written some nice Arduino software to monitor. I guess I could bring mine up here to show you what it looks like. So the idea is, you know, if you've got an observatory, it can manage the heating and cooling and the dome and the whole and the safety and observing conditions, all that stuff. Let me jump on the telescope computer here. I guess I didn't have to do it that way, but that's one way to do it. Actually, let me do, well, yeah, I can do that. Not sure what's going to happen. This is a 4K monitor, so I'm not sure what's going to happen here, but maybe I can.
Looks good.
You can see this window here.
Yes.
Okay.
It's small.
It's small, but
we can
I
see
guess I could do, I could probably do, maybe not. I thought
you
maybe
can't
I could
scale it,
zoom it.
maybe?
Yeah, I'm trying. Control plus, here we go. Does that help?
Yep.
Yeah, so this is this observatory control system. So it's all Arduino based and just various sensors, weather sensors that are connected to it. So just this is the overview, and it's all modular. So you add there's a config file where you say, you know, I've got a rain sensor and I've got a sky quality sensor, and so you just add all that stuff in and what your limits are for safety and unsafety and stuff. So see here, it's telling me it's unsafe to observe because it's very cloudy right now. So this is the just the main status panel, and I added in the DC power supply voltage there. And then I've got a thermostat. You know, again, I don't have an observatory, but the box that I put all this stuff in is too small and it gets hot. So I put a fan in there. So you know, the fan turns on at a certain temperature. And then you've got weather, and I've added these weather sensors. And then you can click in here to see the graphs.
Glenn, why is your power supply reading 11.4 or 11.6?
It's just the voltage drop between the mount and the cable going across to the observatory control system. What's going on here? Is this thing offline? Well, there should be graphs here. I wonder if I ran out of disk space or something. I haven't looked at the graphs in a few weeks, but anyway, you you get graphs of everything, but for some reason mine's not showing up. I'll have to troubleshoot that. But there is an ASCOM driver. That part's not open source. The rest of this is open source that you can hack and slash. But you pay, I think, $10 or something for the ASCOM driver, and so SGP can consume this safe and unsafe, you know, to see if you should be observing or not. So it's just was a fun COVID project. Lots of electronics and a certain amount of packaging, which I didn't do very well, which could be done better in terms of exposing the weather sensors to the sky in the right way and having it be rain tight and all that stuff. So it was a fun project.
Very cool. And you,
Yeah, and if I'm not wrong, that was the let's say the wired version. Because you have your Ethernet connected to the unit. Correct?
Yeah.
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 Yeah. Instead, I've done the other version with the Wi-Fi.
Yeah.
With the Wi-Fi. Yeah.
Yeah, it's a Arduino Mega with Ethernet board on top. Yeah. And then if I was going to get serious about it, if I had an observatory, you know, there's the hardened versions of these boards that you can pay a lot more money for that are supposed to be idiot proof, which I need. So, yeah.
Instead, I'm using the ESP board that are sort of mega Arduino or bigger Arduino with 4 megabyte of memory. So you have a lot more. And they have the Wi-Fi integrated inside the board. The same, more or less the same that the water quality sensor used.
Okay.
You have not connected or found if there is any correlation between the seeing and the air quality value?
No, there hasn't really been any fog, if that's what you're asking about.
Mhm.
I haven't had really a marine layer, but yeah, that's one thing that I'm curious about, as you know.
Yeah.
Other than that, the only thing that's not working is the wind sensor. I mean, I'm getting the temperature from the outside temperature via the wind sensor, but for some reason the wind sensor itself always reads 0. So, and I'm on my second one, so I still need to troubleshoot that. I'm
Yeah.
sure it's a connection problem, but
The damn USB, probably.
well, no, the connection between the sensor and the Arduino board.
Okay.
Yeah.
Okay.
Like it is one of these projects that you've learned enough to go back and start over, right? And you do it right the second time. But
Yeah. Too many projects.
oh, by the way, this is sort of out in the weeds, but one of the things in this astronomical spectroscopy book is there's a teardown of that flip mirror. So I can finally figure out how to get the damn knob off the thing so that I can make a better mechanical connection to the knob. But in here they teach you how to tear it apart and make it into a beam splitter. But the teardown instructions will be handy for me in any case, I think. So I think that's everything I wanted to mention, Bruce.
Okay.
I'll just
Well,
be on the lookout for PJ's big suck he mentioned for imaging Mars.
wow. Maybe we should have a T-shirt made for that.
Yeah.
Okay. Anybody else? All right. Well, if any of you guys have anything that you want to present next month, we're wide open. I'm going to continue looking for a presenter. And the way things are ramping up with COVID, I doubt we're going to have any outings right now. Glenn, do you have any input on that?
Yeah, no, it's not just there's been a few times where I've thought, I should just go do a workshop and just tell people to stand 6 feet apart. But every time it's gotten close, then there's been another, checking the Santa Clara County website or the OSP, or there's high fire danger, and the OSP has said no. So right now we just don't have permission to take anybody but docents to an OSP site. So I guess that could be maybe some, small group of people doing some observing, but not members of the public. And I guess now that it's wet, the fire danger is not really an issue, maybe, but that was the other problem.
Yeah. Okay. Well, we'll keep our fingers crossed, and hopefully things will improve. Okay. Well, thanks for coming, everybody. Stay safe, and hope to see you next month. All right. Or sooner. Take care.
Bye, everybody.
Bye.